thread,
But as a constant.
yeah, it's constant, but it's stored as a scalar variable at SV. SVs belong to one thread and are not allowed to be looked at by another thread. So there has to be an indirection to the pad, because the pad is cloned, so that when you start a new thread, you've now got 2 copies of the pad and 2 copies of the constant.
Right. Okay, well. I suspected something like that, but anyway, it caused me some grief. Because if you try to execute our constant accessor method, then we're just basically going to die. And we have to use precisely the same code we're using. We have to use for constant precisely the same code as we used for variables in the normal world. For threaded variables, we have to use something else. Anyway, those complications are minor things. The general idea is, I hope, clear. And the actual parser is coded pretty ad hoc. I didn't use any of the parsing modules because it was relatively easy to just go down, especially I don't care about so many things which code does. Right? So okay, does it look like a variable? Does it look like a method name? Does it look like the attribute value? Does it look like an if? Okay, now we go with this branch, otherwise just basically ignore it or fail out because it's not a valid database variable. Right, and of course it is pretty recursive, but you cannot avoid recursion with strings. And it doesn't build a scale directly, it builds a data structure, which is not quite the abstract tree, but it sort of has bits and pieces of the future very close and then some more stuff together. I mean, it's just a normal problem. Right. It turns out, I wasn't really aware of it until pretty recently, that this parsing stuff is actually pretty small. Right? It's probably not really relevant in the vast majority of cases because you're going to the accessing database. Hey, I mean, but in some instances it is important. Those 2 ISOT guys, Ivor and Henrik, they wrote this Markov engine, which is basically a pretty nice chatbot called Pilot. And they were actually using the explorations in the first version, but then they replaced it with plain DBI. And when I asked why, they said, okay, we did the requirement stuff, which is next step. More talk. And it turns out that it just spends too much time parsing. So I decided to give it a go. And the natural case, yeah, well, I'm looking at most of them, at least in this slide, the natural thing to do is just to avoid some duplication. So that you do not parse, if at all possible, you just have this as already. Okay, here you go. So what to cache is pretty obvious, but what is our cache key is a little bit more involved. First of all, we need the location of the treatment memory, because if it has a different location, then it's a different code. So we are not allowed basically to reuse whatever we parse something listening. Then it's actually not enough because it could freeze the code and allocate at precisely the same location. So, and I still don't have a perfect solution, but I have a solution which always works, because if I add the location in the code, the file and the line number, then basically it never happens this overlap problem with real location. So it's a bit tricky. I mean, theoretically speaking, it could probably be a problem, but well, I don't think so. Not really. And then, of course, we need to store our database type in about all those y variables which change? Because, okay, so SQL in this case will be precisely the same, right? Because we are using the bind values, we are using the question marks. But the actual values will be different. So we cannot cache just the value, it will be different. What about caching the B shadow of the value? Turns out no, we cannot do that. And to test it, we could get our city, we could get our file name, and print out the memory location. That's all fine. Then we already saw this particular very simple sub-parsing thingy. And then we print out the value of the B shadow object and the value itself. And we call this fake fetch 3 times. Right? And of course we have the same location. We have the same memory location because it's still the same subject as compound once. The values are different, but the B values are also different. It's different objects. So if we store the first one in our cache and try to access it, then in the best case we will get 4 down. And in the worst case we get 0 value, which is just so, and the solution turns out to be, instead of storing the value of its shadow, we just store the operation for each mixed and we already know how. So we store the operation, we save the pub list. When we detect the cache hit, then we take the current pub list of what's happening because it might have, or most likely it have changed. And then we have in the new pub list and the old operation with the value we will extract the current. Right. So we still do a little bit of parsing, but multiple just those things can get to the value. Right. Unfortunately, I had to introduce an incompatible change to the model because I was too clever when designing Perlish. And I decided, okay, if we have a comparison and the value is undef, replace the comparison in SQL with is good or is not good. Right, and if it has a change in value of the cache, then yes, it would be possible by doing the extensive modifications of my internal data structures to actually handle the situation, but I decided, okay, it's not worth the trouble. In simple rules handle very specially. They're going to handle very specially as undef here as well. So this particular construct will not do this cache the same thing in the previous versions of the model. But that's okay, because we have another way of doing it in our invented language, and that always worked. Define the model. Right, the next caching problem is, of course, conditional calculation. Right, what we do in this case, because we have precisely the same sum, precisely the same location, but depending on the value, we generate actually significantly different scalars here. And cache key looks the same, but well, isn't. So what I do in the current code is basically I remember, okay, that value was a conditional, and that value was a conditional, and this value was a conditional, and in total we used like 3 conditionals in the query sum. Okay, fine. So when I know that, and I know how many conditionals and what was the operations for them, I just re-evaluate them at the point of cache key, and then I just compose a binary string of zeros and ones and blend it to the cache key. So previously it would be something like that, and now with those conditionals, the false, true, false. So that basically means that for all 8 possibilities to go to the parsing, but only once for every possible encounter. And after that, it will be cached and pass again. And of course, we have more troubles like variable table names in here, and variable column names and whatnot. So there are other cases when it's not exactly clear what the cache key should be. So, but for now, I just basically decided, okay, if you see something like that, I give up. Maybe in the future it's a moving target. Maybe I will do something. But for now, the already reached speed up is such that okay, good enough. So it is a moving target. And here are some benchmarks. They have the minimal possible valid query sub, which is just basically the table name. And on this laptop, I'm getting about 1,500 calls per second not cached and about 11,000 calls per second cached. So decent enough. And this difference becomes much more pronounced with more complex query sub use. And I was thinking, okay, if you are doing this reparsing to get to the values, then the more values you have, the less effects of caching should be. But it turns out not to be that bad. So the last two benchmarks are with, I think the third one is with a couple of variables, and the last one was 10 variables, so quite a lot of this parsing, but it's still pretty fast in comparison to the baseline. So, what other optimizations? I mean, seriously, I'm not doing anything special when I do the parsing. It's just normal stuff, get the value, check what the name is, do a different branch, recurse. It's just a parsing. How slow can it be? So I haven't verified it, but I think that it's just that this B shadow stuff is pretty slow by itself, and I use it a lot. It's like thousands of calls made. So maybe it's actually worth to try and go into the B window and try to see why it's so slow and speed it up, and then not just the Perlish, but some more stuff with them. So I think I'll really go. Right, and that's basically more or less it with talk. So the slides will be at the URL soon. And right now the caching version is not on cPanel because I'm very scared of caching. I just don't want to out with the old SQL valid. So I'm working on tests. The code is ready, but I'm just extending all the tests like crazy. But I think in a couple of days I'll probably some new version. Thank you very much. Do you have any questions? Yes?
Come on, we can go. Well, yeah, that's pretty cool. I like the talk and I like the idea. Specifically about caching, it might be the way qualified UTF-8 cache works now, it can go in 3 modes.